Today, we want to continue looking at trigonometric functions, and we're going to stay in the context of solving right triangles. So remember, the solving right triangles game is that I give you three things and you find the other three. Given three, find three. The solving triangles game is about given three, find three. Solving right triangles brings a certain tool set online because one of the things that you're given is a right angle. So when I say solving right triangles, one of the things one of the three things that you're given is a right angle. So it's a right angle plus 2. What this means is that when we have a right angle as part of our given information, is that we get to use things that involve the hypotenuse. In particular, by solving right triangles, we bring a new tool set into play. So if we have a generic triangle, did I make A the vertical leg? It doesn't matter, I'm just trying to be consistent. So if we have side A, that's going to be opposite angle alpha. And side B will be opposite angle beta. The only generic piece of information that we have is that the sum of the angles of a triangle is 180 degrees. Alpha plus beta plus 90 is 180 degrees. In the category of right triangles, since we knew one of the angles is 90 degrees, we can just say alpha plus beta is equal to 90. So that's one of the tools that we have in our toolbox. The other tools that we have in our toolbox for solving right triangles is the Pythagorean Theorem. Which gives us a squared plus b squared equals c squared. Another important tool that we have in the toolbox for right triangles and then we needed some connection between angles and the sides. So we set up our trig functions. So I want to name the legs of a triangle relative to an angle. So once we decide on an angle, I'll call it theta, we can decide what's the angle opposite theta and the angle adjacent to theta. The hypotenuse is always in the same place, opposite the right angle. But this gives us our trig functions. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Even though the tangent doesn't involve hypotenuse, this interpretation of tangent only works in right triangles because we have to be able to call something opposite and adjacent. And if the third one is not hypotenuse, I don't know which of those legs to call the adjacent. I have to have one choice for adjacent, and that means that the other adjacent side is the hypotenuse. So even though we're not using the word hypotenuse here, the word adjacent depends on us having a hypotenuse. But here's our other tool set. And these are all the tools that we need for solving right triangles. We don't have to memorize these tools, but we do have to remember them. So if that means that requires that you sit down and memorize all these facts, then so be it. What's that? And the inverses. This is the core set, and then we have to learn how to use the items. And using the inverses is one of the ways that we use them. So we first learn this list of 5 things, and then we have to learn how to use those 5 things. We have acquired the circular saw. Now we need practice using the circular saw. We can't just say, buy a circular saw and hope for the best. But that's a recipe for cutting off a finger. Yes. Now they have saws that will protect your fingers. Yeah, I think that's what it does. And the saw's like, ah! It does. The saw sacrifices itself to save your finger. I got into a low-speed crash in my car. My car, it was a 2003. And that was a new enough car that even though it was a low-speed crash, the crumple zone's like, oh no! And it totaled the car, which is pretty harsh. But it's not like we can program the car to have judgment about whether it's going to be a serious crash or not. It can just be like, oh, I just got to absorb the impact. And so, you know what I mean? It's like some people are like, I'm going to drive an old car because it's easy to work on. It's also trying to kill you. I mean, unsafe at any speed, that's a super overreaction. What that was talking about, like specifically the Corvair. But there's no doubt that every car in that era was trying to kill you. They're dangerous. But now every car is just going to sacrifice itself. It's going to be a little look out. So this is your tool set. Now you have to learn how to use the tool set. If we set these up with our angles that we have over here, if I wanted to say if I knew something about A and the hypotenuse, A is opposite alpha and adjacent to beta. So if I had A and C, I could use that to find beta or find alpha using cosine or sine. So I could set up sine of alpha is opposite over hypotenuse, but I could also say cosine of beta is adjacent over hypotenuse. Notice that the sine of alpha and the cosine of beta are the same because A is opposite alpha and adjacent to beta. If I set up the sine of beta, we would take the opposite beta is B and the hypotenuse is C. Also, the cosine of alpha is adjacent over hypotenuse. B is adjacent to alpha and opposite beta. This actually produces a useful result that showed up in some of the homework that you might remember. Alpha and beta are complementary. They add up to 90. Notice that when we take the cofunction of the complementary angle, it's equal to what we started with. So we can interpret this, we can combine this, and we can note that the sine of theta is the cosine of the complement sine of theta is cosine of 90 minus theta. We could also say that cosine of theta is the sine of 90 minus theta. Cofunctions and complements. Oh, I saw someone. Anybody else see that, or did I just hallucinate? Okay. That's fair. Hey, fascinating. Like sometimes students ask, how long do we have to wait before the instructor is declared missing and we can leave? It's like 0 seconds. If you like walk in here at like 1 o'clock or 10 minutes while you're like, oh, Leach is not here, I guess I'm going home. That's 0 seconds. It's the amount of time you have to wait. We can also do a similar thing with tangent, although I haven't defined cotangent yet, so I don't have the cofunction for tangent. But if we look at the tangent of alpha is opposite over adjacent. So that would be A over B. And the tangent of beta would be opposite over adjacent, and then to flip things over, B over A. You may notice that there were, in the reading and in the homework, that there were 3 other trig functions: cosecant, secant, and cotangent. And you're like, oh, dude, why did you not mention these? So I left them for you to read about them. I know, dick move on my part, but that's the way it goes sometimes in my class. Sometimes I go, I'm just going to leave that for students to read about. I even had time to talk about it on Thursday. I didn't let it go. One of the things that we want to point out here, we have cosine of theta is sine of 90 minus theta. This is in trigonometry what we can call an identity. This is something that's always true. Regardless of the value of theta, this is always true. Usually when you get stuck on a trig problem, either in this class or when trig gets involved in your future classes, like in calculus or whatever, if you get stuck on a problem involving trig functions, start remembering your identities. Think, is there an identity that can sneakily get me out of this problem? That's probably where you're stuck. You're not remembering some identity. And then you'll be like, oh, wait a second. I can replace cosine of 90 minus theta with sine of theta. And now my life is easy. Thanks, trig identities. Now, these are just tools that we have available. We have to learn how to use these tools to solve for various things. So let's just grab one of these as an example. So let's suppose that our given information was alpha and A, sum 2 of alpha, A, or C. I have to be able to solve for any one of these 3 things using this relationship. Given A and C, I got to be able to find alpha. Given alpha and A, I have to be able to find C. Given alpha and C, I have to be able to find A. Given 2, find the missing piece. You have to be able to be given 2 and find the missing piece. So the easiest thing to solve for is A, because I could just multiply both sides of the equation by C. So A is equal to C times the sine of alpha. The other thing, this is if we're given C and alpha, this is how we would solve for A. if we were given alpha and A, and we want to solve for C, notice that C is in the denominator. So I want to multiply both sides by C and then divide by the sign of alpha. So if I wanted to use this information to solve for C, I would take A and divide it by the sign of alpha. We can also use this to solve for alpha. So if the sign of alpha is A over C, we just got to get alpha by itself. And so that's when we're going to do a sine inverse. So sine inverse, to get alpha, that's when we have to do the sine inverse. Sine inverse of A over C, or arc sine A over C. To get sine inverse on your calculator, you just press second and then the sine button. And that's how you get the sine inverse button. That's how we get the sine inverse key, or also arc sine. Arc sine is just another word for sine inverse. Back when we invented the inverse trig function, sine inverse, we said we should call this something else so that people don't get confused with this being sine to the -1. And then everybody else in the room is like, oh, well, we could call it arc sine, but that's a lot of letters. It's like, well, yeah, but I mean, it's looking like an exponent. So, people will understand it's an exponent. And then we started teaching trig, and we got back together. It's like, well, some of them are reading it like an exponent. And then there was like one guy's like, well, I told you. And then we're like, oh, but you went along with it. Like I was there. Don't blame me. Just a messenger here. So here are the ways that we could use this fact. We set up the relationship with 2 of the 3 things filled in, and then we solve to find the third one. The tricky one is the sine inverse one because we have to use different keys. The other ones are just turning around multiplication and division. If you read sine of A over C, that's like saying that 3 is equal to 6 divided by 2. And we can solve this for the 6 by saying 6 is equal to 3 times 2. Or we could solve it for 2 by saying 2 is equal to 3 divided by 6 divided by 3. If you've been in my class before, I always start off with 3 times 2 is equal to 6. It's the one that I use to turn things around. So when I'm looking at this, this is a division. I'm thinking 3 is 6 divided by 2. So if I want to get the 2 by itself, 2 is equal to 6 divided by 3. That's just trying to exploit the relationship between multiplication and division rather than having to think about solving by doing the same thing to both sides of the equation. Ultimately, whatever works. I think it's a little more flexible if you understand the relationship between multiplication and division. Any questions? Dang it. A little better. Any questions? Comments? Any thoughts? Yes. Yes. Yeah, it's not paper, it's plastic. I use because I go through a lot of it, I use oh, it's not on there. It's a rocket book. This is not a sponsored video. but I use a Rocket book. So it's like 15 plastic sheets that you can erase with just water. You have to use a special kind of pen. So, but they're pretty readily available. It's Pilot Friction. It's a gel type of pen. Yeah, I know. I switched over to this because when I was just using paper, throughout the semester, I'd be using at least 2 reams of paper just writing notes. And then they still got scanned, still got posted. And then I just had all these notes and they just went into the recycling. And I was like, well, I hate this. And then there's also like those computer, like tablets. But I needed multiple colors, like the early ones were just black and white. And then I got this for Christmas. Because my spec was like, oh, I'm just looking for something that I can rewrite on, but then I have to be able to use multiple colors because I like using multiple colors. And the only ones that I had seen so far were like black. You had to use a black and white. And then my wife's like, oh, Merry Christmas. And I'm like, yeah, I do all the time. I'll get down to here and write something and I'll need to make a correction up here. So, and it takes a long time to dry. So that's why I got the flip one. So, oh yeah, because left-handed, you're going to be like dragging over. You're going to have to really modify your writing style or start writing backwards. I actually got really proficient at writing upside down. Because I'd work as a tutor, and I'm right-handed. So if you were sitting here at this table, I'm like, oh no, you have to sit here because I'm right-handed. And they'd be like, oh what? And then I would sit down. I'm like, oh, see, now you can copy off of me, right? We can write together on the same thing. But sometimes it was like someone here and someone there, and for that person, I had to learn to write upside down. I guess I didn't technically have to learn to write upside down. I just got bored and started practicing writing upside down. And I got really good at it, stopped doing it, now I can't do it anymore. Any questions on solving the triangles with each of these things? One of the important things to keep in mind is that you start off knowing 3 pieces of information. Once you have 4 pieces of information, you'll very often have choices about what to do next. The most important thing to do is something. And this is just true for math in general. The most important thing to do on any problem when you get stuck and you don't know what to do next is something. You have to pick something and try it. It's the only way forward. You have to be willing to try something and have me say, no, that's wrong. That has to be on the table. You're trying to learn a skill. It's a really weird, arcane skill. You got to be ready to be wrong. If you're going into science at all, you got to be ready to be wrong. I know, it's terrible. Because when you're in science, the thing that you're trying to do is prove yourself wrong. You don't go around trying to prove yourself right. You try to prove yourself wrong. All right. Is that? Yeah. If you're going into law, then you definitely don't want to do that. All right, let's take 5. Come back and talk about, I do want to talk about rounding, because I saw that that was a little bit of an issue on some of the problems. All right, take 5. 5 minutes.